Good morning and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones and we're bringing you live coverage from Mission Control Houston of the upcoming return-powered flyby, in which Orion will fly behind the moon and perform a burn utilizing the orbital maneuvering system to send it on a trajectory back towards Earth. This engine has been used numerous times throughout Orion's journey thus far, following Orion's launch atop the Space Launch System on November 26th. All spacecraft systems are performing well, now 20 days into the flight of Artemis 1. Today, we're in the White Flight Control Room, where Flight Director Judd Freeling is leading the team on console for today's flyby and burn. We do expect to lose signal of Orion as it travels behind the backside of the moon, as the moon will be blocking the direct sight to the Deep Space Network. We're tracking that loss of signal to begin at 10:41 a.m. Central this morning and will last 30 minutes. While in the loss of signal, the return-powered flyby burn will take place with the Orbital Maneuvering System engine at 10:43 a.m. Central. This will be the longest burn of the mission so far. The burn will be 3 minutes and 27 seconds long, about 1 minute longer than the outbound-powered flyby, where Orion was placed in a trajectory to head out to deep space. That burn occurred successfully on November 21st, and the outbound-powered flyby sent Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion remained in the distant retrograde orbit for one long elliptical orbit around the moon, lasting about 6 days. We're now on the return journey of our trip, and this last big push will bring Orion on the trajectory to head towards home. You are looking at a view of the moon, a live view, as well as the Orion spacecraft. Right now, Orion is 5,680 miles away from the moon. Orion is traveling at 3,800 miles per hour, and Orion is over 230,000 miles away from planet Earth. At the closest approach this morning, Orion will be about 80 miles above the lunar surface. That closest approach will occur when we are behind the moon in that period of a loss of signal. We're about 2 hours and 38 minutes away from today's return-powered flyby burn. Again, this burn will occur with the Orbital Maneuvering System engine, or OMS engine. This engine has been used for a variety of burns so far on the mission. And you're looking at a view here on your screen of the Orion spacecraft. That large engine on the very bottom of the European Service Module is the Orbital Maneuvering System, or OMS engine. This main engine is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space many times before. It actually flew on 19 space shuttle flights, beginning with STS-41G in October of 1984 and ending with STS-112 in October of 2002. Now, the OMS engine is not the only engine on board Orion. There's also 8 auxiliary engines, which you see a few of here. Those are also located on the bottom of the service module in 4 sets of 2. Each of these engines can provide about 100 pounds of thrust, and these engines provide steering and can pulse on and off during burns. Again, this is a live view from the Orion spacecraft. Orion is 5,500 miles away from the moon, but closing in. At closest approach later this morning, Orion will be just 80 miles above the lunar surface. Orion has had quite the journey, now 20 days into this 25-and-a-half-day mission. Notably, during this flight, Orion beat the longest distance ever traveled for a human-rated spacecraft meant to return home. At its furthest point from Earth, Orion was 268,563 miles from our home planet. The views you're looking at right now of the moon are being gathered with the SAW cameras, or solar array wing camera. The solar array wings are those X-shaped wings that stick out of the bottom of the Orion vehicle, and they are used to collect solar power and distribute to the vehicle. But on the very edge of these wings, are cameras. As you rotate the solar array wings, you are able to capture different views of not only the vehicle itself, but also of both the moon and, earlier on in the mission, the Earth. If you're just joining us this morning, we are bringing you live coverage of today's outbound powered flyby burn. This burn will bring Orion in a trajectory to head back home for a splashdown on Sunday, December 11th. We are anticipating that burn to begin at 10:43 a.m. Central Time. But while we look ahead to the return-powered flyby, let's take a look back at some of the highlights from this historic mission so far. First up, we have the Space Launch System launching from Pad 39B at the Kennedy Space Center in Florida with its sights set on the moon. SLS blasted off at 12:47 a.m. Central on November 16th. Here you see the 4 RS-25 engines lighting up the Florida sky. And this video shows SLS and Orion's climb to orbit from the perspective of a camera on the rocket. It was about an 8.5-minute climb to orbit. And following liftoff and that climb to orbit, the translunar injection burn took place for Artemis 1. The TLI maneuver took place as the upper part of the rocket, officially named the Interim Cryogenic Propulsion Stage, fired one RL-10 engine, producing 24,750 pounds of thrust to accelerate the vehicle to more than 22,600 miles per hour, a velocity fast enough to overcome the pull of Earth's gravity and propel Orion out of low Earth orbit to send the spacecraft to the moon. The TLI maneuver precisely targeted a point above the moon that will guide Orion close enough to be captured by the moon's gravity. And right after that TLI burn, the interim cryogenic propulsion stage separated from Orion, which you did just see a video of that on your screen there. Later that day, we received our very first imagery of Earth, as well as completed the first checkout of the Orbital Maneuvering System engine, or OMS engine, which went smoothly. Orion was officially on the way to the moon, and again, that OMS engine is the same engine that will be utilized today as we bring Orion home. Now, several days later, on November 21st, Orion performed the outbound powered flyby burn with the orbital maneuvering engine as well. This video shows Orion as it approaches the moon for this burn. And following that burn, Orion completed its closest approach to the lunar surface, where it was just about 80 miles above the lunar surface. And then Orion completed the distant retrograde orbit, which enabled Orion to head out into deep space. Now, this photo that you're looking at on your screen was taken while Orion was in that distant orbit. And this was the furthest point that Orion reached during its mission. Orion was 268,563 miles from our home planet when this photo was taken on November 28th. Orion has now traveled further than any spacecraft built for humans meant to return back to planet Earth. And in this photo, Orion's solar rays split the difference between the Earth and the Moon on flight day 14. This image was captured by a camera on the tip of one of the spacecraft's 4 solar arrays. And just last week, the distant retrograde departure burn occurred, which placed Orion in a trajectory to exit distant retrograde orbit and head back toward the moon ahead of RPF today, which we are awaiting and looking forward to. And here's some video just prior to that burn. And you can see Earth there in the almost center of your screen, right behind the solar array. So as you can see, Orion has had an exciting journey so far, but still a few days left in this mission. At this time, Orion is 5,191 miles away from the lunar surface. And we're under 2 hours and 30 minutes away from today's return power flyby burn. Again, this burn is slated to begin at 10:43 a.m. Central and will be a 3-minute, 27-second burn. Again, you're looking at a live view of the moon as it continues to close, as Orion continues to close in. Now, 5,058 miles above the lunar surface. Orion is traveling at a velocity of 3,933 miles per hour and is 234,000 miles from planet Earth. Now, in this image of Earth right now, we actually are able to view several Apollo landing sites rather. Of course, we are a bit too far away to make out any distinct features, but you are looking at the landing sites for Apollo 15, 17, 11, 16, and 14. And you are looking at a graphic here that shows a little more clearly those landing sites and Orion's path as it flies around it. Again, Orion is about 5,000 miles away from the lunar surface, so we won't be able to make out any details. And at its closest approach, Orion will be 80 miles above the lunar surface, still a little too far to make out any of those details. As we continue to get these great views of the moon, we did mention that NASA Flight Director Rick LeBrode is leading the team here in Mission Control Houston inside the White Flight Control Room during today's burn. But let's take a quick look at this video, which discusses the various flight directors of Artemis in a little bit more detail.
Flight CTO and flight loop.
Ready, come for cooling status.
Conoco AOS, good for
Copy.
Flight controllers generally focus on systems, subsystems of the vehicle, and they're more in tune with the detailed workings of their particular system that they're responsible for. Flight directors, on the other hand, are more in tune with what is the integration between all of the subsystems. What are we all marching towards? What's our mission objective?
Prop flight has the RCS holding together with the regs.
Really, your training starts when you become a flight controller. You know, you learn a lot by osmosis, and you kind of get a sense of a little bit of the job, but once you become a flight director, The amount of learning you do is exponential.
You don't become an expert, but you have to understand them at a depth where you could have the good conversation, ask the right questions to the experts who are the flight controllers. You spend a lot of time studying and then training, getting in simulations and running through all the motions and practicing the real-time situation scenarios in the training environment.
I am the Ascent and Entry Flight Director for Artemis 1. I will take responsibility of the vehicle after it launches. I'll also be the entry flight director, so once we come back to Earth, I'll have a team that will monitor and control the vehicle once it splashes down, and we hand that over to Melissa Jones, who is the NASA Recovery Director.
Splashdown.
Touchdown verify.
Copy.
I'm the lead flight director for the mission, really responsible for the overall development of the mission. We work directly with the programs. They provide us the mission priorities, and we build a timeline that's going to accomplish those mission objectives. We're responsible for building our team, getting our team trained and certified. We have a training team that helps us, but we have the overall responsibility for putting together the team that's going to execute the mission.
Confirmation of translunar injection burn cutoff.
When you go to a place like the Moon or Mars, you really have to be explorers. It pushes the boundaries of civilization.
We are having to develop new technology. It's going to have to sustain the astronauts for these very, very long trips. And it just makes sense to test that and going to the Moon, where you're in a similar environment, but you're much closer. And in the event of an emergency type scenario, we can bring them safely back home.
Station, this is Houston.
We've had a lot of experience now in low Earth orbit, over 50, 60 years of experience, and we've learned how to do that pretty well. We've learned what the effects of the body are in low Earth orbit, but there's still things that we need to practice, and we need to be able to understand how you sustain life further and further and further away from our planet.
It's just so different from everything you learn when you do low Earth orbit. And that's what's making it so much fun. I'm every bit as excited about this mission as I was the first day I walked in the doors of Mission Control.
Orion is now less than 5,000 miles away from the Moon, 4,833 miles away to be exact, traveling at a velocity of 3,966 miles per hour. We're 2 hours and 13 minutes away from today's burn. We're still targeting 10:43 a.m. Central for that burn. Everything continuing to proceed smoothly this morning as we anticipate the return-powered flyby burn in about 2 hours and 11 minutes. This burn will last for 3 minutes and 27 seconds and will change the velocity of the spacecraft by 960 feet per second. And this burn will also place Orion in a trajectory to head back home ahead of a splashdown in the Pacific Ocean on December 11th. The next major milestone here in Mission Control Houston is when Flight Director Judd Freeling will poll the team of flight controllers for a go, no-go for the burn. We anticipate that poll about an hour from now. We're just about an hour away from today's anticipated loss of signal. That LOS is slated to begin at 10:41 a.m. Central. We will not have signal with the Orion spacecraft during this time frame because the moon will be blocking any signal to the Deep Space Network. It's at this point that Orion will complete its closest approach to the lunar surface. That closest approach slated to be at 10:43 a.m. and just seconds later at 10:43 and 23 seconds a.m. Central will be today's return-powered flyby burn, which commits Orion to a journey back home. Orion is now 4,571 miles away from the moon, traveling at a velocity of 3,996 miles per hour. Everything continuing to look good this morning ahead of the return-powered flyby burn. That burn will take place 2 hours and 4 minutes from now and will last 3 minutes and 27 seconds long. The burn will take place with the Orbital Maneuvering System engine, or OMS engine, located on the bottom of the service module of the Orion spacecraft. This engine is capable of having burns that last less than 1 minute to more than 16 minutes in length. The OMS engine is the main engine on the European service module and provides the primary propulsion for Orion's major in-space maneuvers. The engine produces 6,000 pounds of thrust and is equipped to steer the spacecraft, and it can also be used in some abort cases to safely return Orion to Earth should that be required. The OMS engine is actually a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space before on 19 Space Shuttle flights, beginning with STS-41G in October 1984 and ending with STS-112 in October 2002. There are also 8 auxiliary engines on Orion. These are also located on the bottom of the service module and can provide trajectory correction. And there are 24 smaller engines grouped into 6 pods, which can provide attitude control as well. So in total, the service module has 33 engines. But today, for the return power flyby burn, we'll only be using one of those, again, the Orbital Maneuvering System, or OMS engine. Everything continuing to look good here in Mission Control as Orion closes in on the moon ahead of today's return-powered flyby burn. Before and during the Artemis 1 mission, we asked the public to share your moon-inspired creations with the hashtag NASA MoonSnap. We have received thousands of submissions, but here are just a few of them. This is a mural painted by Nikki Adams. You can clearly see the Space Launch System rocket as well as the Greek goddess Artemis, after which the Artemis missions are named. Artemis is the goddess of the moon and the hunt, and I think you can see her arrows and a deer included in the mural as well. Next up, we have a photo submitted by Jessa Rodriguez. The title is Ben and Sophia Plot Their Course. You can see the inclusion of Snoopy in his flight suit as well. Snoopy is our zero gravity indicator aboard the Orion spacecraft. And the Snoopy inside Orion right now is dressed very similarly to the Snoopy in this photo. What we see here is a 3D printed art piece from Terramoto. The artist entitled this piece Lunar Specimen 001 and used real data from the Lunar Reconnaissance Orbiter to create this. LRO data is also being used to determine where astronauts will land on the moon during the Artemis 3 mission. And the last image we have to show you today is from STEM educator Susie Bennett. She taught her 130 students about the Artemis 1 mission and even got them to fill out boarding passes. There are currently 3.4 million names of the public flying aboard the Orion spacecraft safely stowed on a flash drive. Thank you to everyone who shared your moon-inspired creations with us. If you're interested in participating, just use the hashtag NASA MoonSnap. We're continuing to get some great imagery of the lunar surface here as Orion is 4,227 miles away from the moon, traveling at a velocity of over 4,000 miles per hour. This imagery is coming from a camera on the solar array wing, or SAW. We expect to continue to get imagery up until the point that Orion does go behind the moon and is in that loss of signal period that we've discussed. That will be a 30-minute loss of signal period beginning at 10:41 a.m. Central Time this morning. And just 2 minutes after the LOS begins, or that loss of signal period, we will have the return-powered flyby burn occur at 10:43 a.m. Central, lasting 3 minutes and 27 seconds, utilizing the Orbital Maneuvering System engine. This is Mission Control Houston. You're looking at a telemetry-driven animation of Orion as it travels at 4,000 miles per hour, closing in on the moon, now 4,131 miles away. Orion is 234,940 miles away from home. Orion launched on November 16th and is in the 20th day of its 25-and-a-half-day historic test flight mission. Orion is an uncrewed test flight, but is performing critical checkouts of its systems ahead of a crewed test flight as part of Artemis 2. Throughout this mission, Orion has completed several milestones, including flying behind the moon once already as part of the outbound powered flyby. During that, a burn took place, which put Orion in a trajectory to head out to deep space. The distant retrograde orbit burn also occurred, which further propelled Orion into that trajectory. And Orion remained in deep space for about 6 days and broke the distance record during that time frame for the farthest distance from Earth traveled by a human-rated spacecraft meant to return home. Orion, at its furthest point from Earth, was 268,563 miles away. Following that, Orion hung out in deep space for a little longer, and just a few days ago we had the DRD burn, or distant retrograde departure burn. This burn put Orion on a trajectory to head back towards the moon ahead of today's return-powered flyby burn. Today's burn is critical to ensure that Orion is on the proper trajectory to return back to Earth safely. We are now 1 hour and 42 minutes and counting away from today's anticipated loss of signal as Orion flies behind the moon and performs the return-powered flyby burn, which will set us on a trajectory to return back to Earth and splash down in the Pacific Ocean on December 11th. But now, as you can imagine, this moment can certainly be a bit suspenseful as we await Orion to emerge from the backside of the moon and regain communications with the Deep Space Network. So let's hear from one of the INCO flight controllers about how much that is the case in this next clip.
During each mission to the moon, we'll have a period of time where the spacecraft goes behind the moon and we lose line of sight with the spacecraft from the DSN stations. That can be quite a nail-biting time. Usually we're executing an important maneuver or a burn during that time, and we have a predicted time when we should reacquire the signal, and so everybody is usually staring at that clock. As soon as the signal comes in-house, there's a sigh of relief, and we check to make sure that the burn executed correctly and that the spacecraft is in good health.
So again, we are anticipating that loss of signal to begin an hour and 41 minutes from now. Today's loss of signal will last 30 minutes in length, during which time Orion will complete its closest approach to the moon and just seconds later perform the return-powered flyby burn, which will last 3 minutes and 27 seconds and will change the velocity of the Orion spacecraft by 960 feet per second. Orion is now less than 4,000 miles away from the lunar surface, 3,780 miles to be exact. And Orion is traveling at 4,115 miles per hour. Everything's still continuing to look good here in Mission Control Houston as we anticipate the return power flyby burn occurring at 10:43 a.m. Central, an hour and 41 minutes from now. Today's return power flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft into a trajectory to return back to Earth. During Orion's mission, it surpassed the furthest distance for a human-rated spacecraft meant to return home at over 268,000 miles from Earth at its furthest point. Prior to the distant retrograde departure burn, Orion was in deep space in a distant retrograde orbit. This orbit is called distant due to its high altitude from the moon. It's about 40,000 miles past the moon in its orbit. This orbit is 30,000 miles further than the previous record set during Apollo 13, and again is the furthest in space any spacecraft built for humans has ever flown. The orbit is also called retrograde because Orion traveled around the moon opposite the direction the moon travels around Earth. Distant retrograde orbit provides a highly stable orbit where little fuel is required to stay for an extended trip in deep space in order to put Orion's systems to the test in an environment far from Earth. The orbit that Orion completed in this mission is different from the orbit done during the Apollo program, in which the spacecraft orbited much closer to the lunar surface in a more circular fashion. It's important for us to learn about how a spacecraft functions in a deep space environment because as part of the Artemis program, the Gateway program is building a small human-tended space station orbiting the moon that will provide extensive capabilities to support NASA's Artemis campaign. Gateway will be built with international and commercial partnerships and will support sustained exploration and research in deep space, and will include docking ports for a variety of visiting spacecraft, as well as space for crew to live and work, and onboard science investigations to study heliophysics, human health, and life sciences, among other areas. Gateway will be humanity's first space station in lunar orbit to support NASA's deep space exploration plans. But before we get to that point, we are testing out the Orion spacecraft as part of the Artemis 1 mission. Again, we're 20 days into a 25-and-a-half-day mission. And today's return-powered flyby is the next major milestone in Orion's 25-and-a-half-day mission. This burn will slingshot Orion around the moon and place it on a trajectory to splashdown in the Pacific Ocean on December 11th. We're now 1 hour and 35 minutes away from today's return-powered flyby burn. Orion is currently traveling at 4,157 miles per hour and is 3,529 miles away from the moon. Just prior to today's return power flyby burn, Orion will complete its closest approach to the moon. At closest approach, Orion will be 79 miles above the lunar surface. This closest approach, as well as the burn, will occur in our anticipated loss of signal period. That loss of signal slated to begin an hour and 32 minutes from now and will last 30 minutes long. The reason we will not have signal with the Orion spacecraft is because the moon is blocking the connection to the Deep Space Network during that time period. Again, today's LOS will be a 30-minute long loss of signal, but we are anticipating to regain communications with the Orion spacecraft once it comes around to the other side of the moon and is able to regain communications with the Deep Space Network. At that point, flight controllers here in Mission Control Houston will be able to analyze today's 3-minute and 27-second return power flyby and make sure everything performed as expected. If you're just joining us this morning, we are bringing you live coverage of today's return power flyby of the Orion spacecraft, an uncrewed test flight as part of the Artemis program. Today is flight day 20 for Orion, and there are about 5.5 days left in this test flight mission. Leading up to this event, today, the return-powered flyby, there have been several other key milestones that Orion has reached, so let's take a look back at the past 20 days. First up, we have the Space Launch System launching from Pad 39B at the Kennedy Space Center in Florida with its sights set on the moon. SLS blasted off at 12:47 a.m. Central on November 16th. And here you see those 4 RS-25 engines lighting up the Florida sky. You can also see the orange core stage as well as one of the 2 solid rocket boosters in this view. On the very top of the vehicle is the launch abort system and, of course, the Orion spacecraft, which is now closing in on the moon ahead of today's return-powered flyby burn. Now, in this video, you have a launch from the perspective of a camera located on the Space Launch System rocket. This video shows SLS and Orion's climb to orbit. It was about an 8.5-minute climb to orbit. You can see the rocket soaring over the launch pad. Following liftoff and the climb to orbit, the translunar injection burn took place. The translunar injection maneuver took place as the upper part of the rocket, officially named the interim cryogenic propulsion stage, fired one RL-10 engine, producing 24,750 pounds of thrust to accelerate the vehicle to more than 22,600 miles per hour, which is a velocity fast enough to overcome the pull of Earth's gravity and propel Orion out of low Earth orbit to send the spacecraft to the Moon. The translunar injection maneuver precisely targeted a point on the Moon that helped guide Orion close enough to be captured by the Moon's gravity. And right after the TLI burn, the interim cryogenic propulsion stage separated from the Orion spacecraft, which you did see in this video here. You see it floating away in the distance. Later that day, we received our first imagery of Earth, as well as completed the first checkout of the Orbital Maneuvering System, or OMS engine, which all went smoothly. Orion was officially on the way to the Moon. And then several days later, on November 21st, Orion performed the outbound powered flyby, also with the orbital maneuvering engine, rather. The outbound powered flyby is the sister to the return powered flyby, which will occur today. The outbound powered flyby, as the name suggests, takes place on the outbound portion of the trip, whereas the return powered flyby takes place on the return journey, as Orion is anticipating its return home. In this video here, you can see the Orion spacecraft, as well as the Earth in the distance and the Moon off to the left. This was just before Orion flew behind the Moon as part of that outbound powered flyby. After this, Orion was placed in a deep space trajectory where it completed a distant retrograde orbit. During that time frame, Orion traveled the furthest distance than any human-rated spacecraft meant to return back to Earth had ever traveled. And in this photo here, you see Orion take a photo of planet Earth from over 268,000 miles away. And in this photo here, you can see Orion's solar rays split the difference between Earth and the Moon on flight day 14 of the Artemis 1 mission. This imagery was captured by one of the cameras on the tip of one of the solar arrays, the spacecraft's 4 solar arrays. And just last week, on December 1st, the distant retrograde departure burn occurred, which placed Orion in a trajectory to exit the distant retrograde orbit and head back toward the Moon ahead of the return-powered flyby, which we're looking forward today. In this view here, you can see the solar array flexing, as well as an Earth in the distance there, almost in the center of your screen. So it's been a busy journey for the Orion spacecraft. Again, we're on flight day 20 of a 25-and-a-half-day test flight mission. Orion is now 3,238 miles away from the lunar surface. And we are just 1 hour and 26 minutes away from today's outbound powered flyby burn, which will last 3 minutes and 27 seconds and place Orion in a trajectory to head back home. The next major milestone that we are tracking this morning here from Mission Control Houston will take place in about an hour from now, when NASA Flight Director Judd Freeling will pull the team inside Mission Control for a go, no-go for today's burn. We're continuing to bring you live imagery of the lunar surface from the Orion spacecraft as it continues to close in. Orion is currently 3,091 miles away from the moon, traveling at a velocity of 4,238 miles per hour. If you're just joining us this morning, we are 1 hour and 18 minutes away from today's outbound powered flyby burn. This burn will be 3 minutes and 27 seconds long and will propel Orion around the moon in anticipation of a splashdown off the coast of California on December 11th. Leading the team here in Mission Control Houston during today's burn is NASA Flight Director Judd Freeling. But Judd is not the only flight director here at the Johnson Space Center in Houston, Texas, that is working the Artemis mission. So let's take a look at a few of the other flight directors.
Flight CTO and flight loop.
Buddy, come for cooling status.
Echo AOS, good port.
Copy.
Flight controllers generally focus on systems, subsystems of the vehicle, and they're more in tune with the detailed workings of their particular system that they're responsible for. Flight directors, on the other hand, are more in tune with what is the integration between all of the subsystems. What are we all marching towards? What's our mission objective?
Prop flight has the RCS holding together with the regs.
Really, your training starts when you become a flight controller. You know, you learn a lot by osmosis, and you kind of get a sense of a little bit of the job, but once you become a flight director, the amount of learning you do is exponential.
You don't become an expert, but you have to understand them at a depth where you could have the good conversation, ask the right questions to the experts who are the flight controllers. You spend a lot of time studying and then training, getting in simulations and running through all the motions and practicing the real-time situation scenarios in the training environment.
I am the ascent and entry flight director for Artemis 1. I will take responsibility of the vehicle after it launches. I'll also be the entry flight director, so once we come back to Earth, I'll have a team that will monitor and control the vehicle once it splashes down, and we hand that over to Melissa Jones, who is the NASA recovery director.
Splashdown. Touchdown verify. Copy.
I'm the lead flight director for the mission, really responsible for the overall development of the mission. We work directly with the programs. They provide us the mission priorities, and we build a timeline that's going to accomplish those mission objectives. We're responsible for building our team, getting our team trained and certified. We have a training team that helps us, but we have the overall responsibility for putting together the team that's going to execute the mission.
Confirmation of translunar injection burn cutoff.
When you go to a place like the moon or Mars, you really have to be explorers. It pushes the boundaries of civilization.
We are having to develop new technology that's going to have to sustain the astronauts for these very, very long trips. And it just makes sense to test that and go into the moon where you're in a similar environment, but you're much closer. And in the event of an emergency type scenario, we can bring them safely back home.
Station, this is Houston.
We've had a lot of experience now in low Earth orbit, over 50, 60 years of experience, and we've learned how to do that pretty well. We've learned what the effects of the body are in low Earth orbit, but there's still things that we need to practice, and we need to be able to understand how you sustain life further and further and further away from our planet.
It's just so different from everything you learn when you do low Earth orbit. And that's what's making it so much fun. I'm every bit as excited about this mission as I was the first day I walked in the doors of Mission Control.
Orion continuing to close in on the moon, now 2,774 miles away, traveling at a velocity of 4,300 miles per hour. And you are looking at a view of the bottom of the European space You are looking at a view of the European service module, the very bottom of it there. And you are seeing the large engine there in the center of the European service module. That's the Orbital Maneuvering System engine, or OMS engine. That's the engine that will be utilized during today's return power flyby burn. This is the main engine on the European Service Module and is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space 19 times before, all on Space Shuttle flights, beginning with STS-41G in October 1984 and ending with STS-112 in October 2002. We are now 1 hour and 13 minutes away from today's return-powered flyby burn. That burn will last 3 minutes and 27 seconds, and will change the velocity of the Orion spacecraft by 960 feet per second. You're also getting a great view of the 8 auxiliary engines on Orion. And again, Orion continues to close in on the moon, now only 2,680 miles away from the lunar surface. Following today's closest approach to the moon, Orion will be only 79.2 miles above the lunar surface. We're now 1 hour and 8 minutes away from today's return-powered flyby burn. Everything continuing to move smoothly here in Mission Control Houston. As a reminder, we will lose signal when Orion crosses behind the moon. That's because the moon will be blocking the signal to the Deep Space Network. We are anticipating that loss of signal 1 hour and 5 minutes from now. That will be a 30-minute loss of signal. During this loss of signal period is when Orion will complete the return-powered flyby burn, that 3-minute and 27-second burn that will send Orion on a trajectory to head back home ahead of a splashdown in the Pacific Ocean on December 11th. And if you are just joining us this morning, we are bringing you live coverage of today's return-powered flyby burn here in Mission Control Houston. That burn is 1 hour and 6 minutes away from now and will be a 3-minute, 27-second burn that will slingshot Orion around the moon in a trajectory to head back to Earth and a splashdown on December 11th. But we have been getting some beautiful views of the moon, and I have a very special guest with me this morning. This is Juliana Gross. She's the Deputy Apollo Curator, and she's going to point out some of these amazing features that we have been seeing on the lunar surface in some of the shots that we have been getting. So thank you so much for joining. I really appreciate you taking the time.
You're very welcome. I'm very excited to be here.
Yes, absolutely. So can you talk a little bit about some of the features that we are seeing on the lunar surface here?
Yeah, absolutely. So if you look on the moon right now to the left middle area of the moon there, the bright spot that you see there, that's Copernicus crater. The dark region that is sort of like right in front in the middle center of the moon right now, that's the Imbrium basin. And so these are impact features that we have on the moon. So when the moon formed throughout its history over its 4.5 billion years, has been bombarded by meteorites and asteroids. And for the Imbrium, that's the darker round area that you can see there, what happened is there's a massive crater, and so we call these a basin, and melt from the interior of the moon came up through cracks and then filled that basin crater. And you can imagine that as a big lava lake, and then it cooled to form basalt. The same thing happens at the moment on Earth. Hawaii is erupting, and that brings up basalt from the interior of Earth. So these basalt samples, when we analyze them and we look at these, we can learn something about the interior of the moon. I see that we lost our actual live view, but in this beautiful view that we can see here, you can really nicely see Copernicus right in the center, and that's brighter because it excavates crustal material, which is white or bright, compared to the mare, which are basalt, which is dark. Oh, there we are back. So Copernicus is now in the lower right corner of that image. That's a fairly young crater, and that's why it still appears fairly bright, because over time, when the sun interacts with lunar rocks, it darkens over time. So we call that space weathering. Yeah.
And so we are flying fairly close to some of the Apollo landing sites now. We're a little too high above. We're about 2,000 miles away from the moon still to make out any features. But can you talk about a little bit about what the Apollo program studied in those landing zones, and maybe touch on how Artemis is going to be different, because we're going to be landing in an entirely different spot, right?
Yeah, absolutely. Apollo wasn't so much about science. It was more about like, hey, we're actually going to the moon and we can do it, and like the technology to show that we can do it. Apollo 14 and 12 sort of landed near Copernicus, like south of where Copernicus crater is right now that I pointed out in that region. And so Apollo 14 landed there in 1971, right above the Framora region, which is kind of like south of Copernicus, and it's right at the edge of that big Imbrium basin that I talked about. They brought back a lot of rocks. They were interested in the rocks that were excavated from Imbrium. So there's a lot of impact melt, as we call them, or breccias. And every time a rock gets exposed to like heat and pressure and started to remelt in like an impact event like that, it resets the internal clock. So when rocks form, they record the condition from which they formed, including the age, like the time when they formed. But every time there's an impact event and it gets remelted, that internal clock resets. Now we can take these rocks and then measure the ages of them. And so every time the clock got reset, we now have the age of that impact event. And so we want to know when Imbrium formed, because it's such a big event that happened on the moon, that we can put everything else in relative age to each other. So that why that mission was important. Apollo 12 landed in the Oceanus Procellarum region, which is sort of to the lower left and then going up. It's kind of like where that shaded, like where you kind of stop seeing the moon, you know, the boundary of the shade and the sunlight lit area. The little bright spot that comes up on the, what is that, lower left third of the moon, that is Aristarchus crater. So that's a super bright crater in that Procellarum region, which we're now seeing more and more of. So that's sort of the area where Apollo 12 landed. That landing was to sort of show that we can do a pinpoint landing. So they landed 200 meters away from the Surveyor 3 lander, and they actually brought a piece from Surveyor 3 back to Earth to like really show. And that then paved the way for future missions to like really like, hey, we can do a pinpoint landing. So we can go to like a more difficult terrain where we can land, where it's more ruggedy. And so that's where we went there. And so now you can see even more of the Procellarum region. Most of that is dark gray, as you can see, and so these are the basalts, and that mission brought back a lot of these basaltic materials. And then we can look at the ages, and it turns out that those basalts were very different, and they were younger than the Apollo 11 mission, than the rocks that they brought back, the basalts that they brought back. Now, Artemis is going to be super exciting because we're going to a very different region. So if you look at the surface here, and you can see that's mostly dark gray, so it's mostly basalts. You can see in the upper part of the moon that's still bright. That's what we call the highland crust. So that's the very old crust. So when the moon formed, there was a giant impact between two protoplanets. It collided, created a lot of heat, everything melted. The center part formed and became Earth. And then the debris cloud that surrounded it coalesced and then became the moon. So once upon a time, the moon was covered in a global magma ocean. So it was fully molten, right? And if you have a global magma ocean, you start crystallizing things. So now when you crystallize stuff that is denser than the melt, that sinks, right? And if you crystallize things that are less dense than the melt, that starts to float, like ice is floating on water, right? And so now we have these crystals crystallizing these minerals, and they are less dense, so they float to the surface and they build the crust. These crystals are called plagioclase. They're white. And so your crust that then forms on the moon is white. And that's why the moon looks so bright when you look at this image or in the night sky, because that's the old crust of, you know, the oldest rocks we have, and they're white in color. And so that's why this is so bright. Now the near side, so the side that we see right now, we see these dark patches, which then are the younger basalts that came to the surface once you start impacting it, and you take stuff away, you made these big basins, and then the interior remelts, and that melt comes up to form to fill these craters. That's very special. So it turns out that this Procalarium region where Imbrium sits in, where Apollo 12 landed, where Apollo 14 landed, all these rocks that were brought back, they have a weird component that we call creep. And it's spelled K-R-E-E-P, and it stands for potassium, rare earth elements, and phosphor. That entire Mars region that you can see here is also has iron in it, lots of iron and lots of titanium, but the rest of the moon doesn't really have that. And so geologically speaking, all the Apollo rocks are really, really cool because they're very special, right? So if I would give you 6 missions and you land them on Earth and you land them all in Yellowstone National Park, and you collect all your rocks, right? You get, geologically speaking, really interesting rocks, but they're not representative for the United States or the rest of the world, right? So same happens with Apollo. Really cool rocks, geologically speaking, very interesting, lots of basalts, right? They all have this weird creep component, so they're all creepy. But the rest of the moon is very different, so they're not representative. Now with Artemis, we're going to go to the South Polar region. So that region is more representative compared to Apollo. We don't really expect a lot of basalts there, so that's more like highland region. The South Polar region also has the largest impact basin that we have on the moon, and also the oldest. So if we can bring back rocks from there, we can hopefully date that really, really old impact region, and then get a better idea of when things happened on the moon and establish a timeline. Now we also know that the polar regions are really, really cold. And so ices or volatiles and gases on the moon, they freeze out in the polar region. So when we go there and collect rocks, we can also bring back these frozen samples and then learn something about where the water is coming from, whether it's moon or, there was lots of asteroids and comets that impacted the moon. And then so we can also learn about something about the water that was delivered to the Earth-Moon system, which most likely also ended up on Earth. And so we can learn something about our own history and how the moon formed and evolved over time better than we can with Apollo. We're missing a lot of rocks and processes with Apollo, and hopefully we can fill these gaps with Artemis.
You are a wealth of knowledge. Thank you so much for sharing all of that information. Now, as we continue to get closer and closer to the lunar surface, of course, these features are going to become more and more clear. Orion is now 2,000 miles away from the moon, but at closest approach today, it will be just about 80 miles above the lunar surface. So before you go for the day, it looks like we are starting to get some better views of that area that you were discussing before. Is there any other items or areas that have come into view since we've been chit-chatting that you think would be helpful to point out?
Yeah, so we see Kepler crater, which is sort of to the left and lower left of Copernicus, what I just pointed out. So it's this like grayish area with the little dot in the center. And then if you go from there further to the left, right at where the moon's shades are, so there's still a lower left, that really bright area, that's Aristarchus crater. And that's a really young crater, and it's really bright because it brought up material from that crust that I saw, and that's this white rock. It turns out we have orbital reflectance data. So when we look at the light, the sunlight that gets reflected off the surface, we can make assumptions about the chemistry in that region. And it turns out that that region is, geologically speaking, really, really complicated. So it brought back up old crustal material, but we also see some basaltic material. And in the central peak, we see material that is silicic, so it's really, really high in silica. And that usually means there's some kind of evolved rock. And when we say evolved, on Earth, that usually means like granites and stuff like that. We don't really mean it that way here, but it has more silica content in it. When I say central peak, so what happens when you have a big impact into the crust rebounds and brings a central part comes up. If you think about it, throwing a rock into water, right, it makes a splash, and then the water rebounds and brings a kind of like a central thing up and then plops back down. So if you would freeze that water, it would stand up in the center. So that happens on the moon or on Earth as well, where like the crust rebounds. And so the central peak is the area that is the deepest material that got brought back to the surface. So that is of importance and special interest to scientists, because now we have another window into the interior of the moon to study these things. And it turns out, specifically for that little bright crater there, it's super complicated, and then we're still trying to figure out what we are seeing.
So it sounds like there's definitely much to be learned from the moon, especially through the Artemis program, and I'm sure you're looking forward to getting some of those samples back to be able to study in depth.
Oh, absolutely.
Well, thank you so much, Juliana, for taking time out of your day to chat with us. I really appreciate it. I hope you have a good rest of your day.
Thank you so much, and thank you for having me. This is fantastic.
We're now 50 minutes away from today's return-powered flyby burn. This burn will slingshot Orion around the lunar surface and put it in a trajectory ahead of a splashdown on December 11th back on Earth. This burn will be a 3-minute and 27-second long burn and will be the longest burn of the mission utilizing the Orbital Maneuvering System, or OMS engine. You are getting a view of the OMS engine on your screen. It's in the very top left, the largest engine on your screen. The next major milestone that we're tracking here in Mission Control Houston is the Go, No-Go poll. During this poll, NASA Flight Director Judd Freeling will go around the room and poll each of the flight console positions to ensure that all is looking good ahead of today's burn. Orion is now less than 2,000 miles away from the moon, 1,756 miles, moving at a velocity of 4,563 miles per hour. At this time, Orion is over 237,000 miles away from Earth. And if you're just joining us, Orion is now 1,550 miles away from the moon. We are anticipating today's return-powered flyby burn to begin 43 minutes from now. This burn will last 3 minutes and 27 seconds. During the time period that the burn takes place, Orion will be in a loss of signal period because it will be directly behind the moon, and the moon will be blocking the signal with the deep space network. Today's loss of signal will last for 30 minutes. After we come back around to the other side of the moon, we anticipate regaining communications with the Orion spacecraft, and that's when the team here in Mission Control will be able to analyze the return-powered flyby burn and make sure everything went as expected. This burn is critical as we look ahead to a return and splashdown of the Orion spacecraft on December 11th. Today's burn will put us in a trajectory to enable that splashdown. And on your screen right now, you are seeing some movement here. This is taking place as the solar array wings get into the right configuration ahead of today's burn. A great view of the Orbital Maneuvering System engine, or OMS engine, coming into view on the European Service Module. That's that large engine on the very bottom of the European Service Module, and is the engine that will be used during today's 3 minute and 27-second burn. Again, this will be the longest burn done by the OMS engine so far, but the OMS engine can actually fire for up to 16 minutes if necessary. You're also getting a view of the 8 auxiliary engines on Orion. These engines can fire for less than 1 minute, up to 45 minutes in length. And these engines are used more for trajectory corrections. Each engine provides about 100 pounds of thrust and can provide steering during burns by pulsing on and off. Orion continuing to get in the proper orientation ahead of today's burn. We are tracking that burn 38 minutes from now. And again, during that burn, we will lose signal with the Orion spacecraft. The loss of signal will be 36 minutes from now. You're looking at a view from our data-driven animation of the Orion spacecraft. As you can see, we're now 1,317 miles away from the moon, Orion moving at over 4,700 miles per hour. At this time, Orion is over 238,000 miles away from Earth. Everything continuing to move smoothly this morning as we anticipate the return-powered flyby burn 36 minutes from now. We are hearing that the Orion spacecraft is now in the proper attitude ahead of today's burn. From this view, you can see that orbital maneuvering system engine on the left of your screen, that large engine on the European service module. That's the engine that will be utilized during today's burn. You also see two of the auxiliary engines, as well as two of the solar arrays. On the tip of the solar arrays, on the wings of the solar arrays, are the SAW, or solar array wing cameras. Those are the cameras which are capturing the imagery that you see right now on your screen. Orion continuing to close in on the moon, now 1,100 miles above the surface of the moon. During today's closest approach, Orion will be just 80 miles above the surface of the moon. Here in just a couple of minutes, we do expect NASA Flight Director Judd Freeling to give a go, no-go poll for today's return-powered flyby burn. If the team polls go, then we are anticipating the burn to begin at 10:43 a.m. Central and last 3 minutes and 27 seconds. This burn will slingshot us around the moon and get Orion into a trajectory to return back to Earth and splash down off the coast of California. While Orion is behind the moon today, we will not have communication with the vehicle because the moon will be blocking the connection to the deep space network. However, once Orion swings back around on the other side of the moon and regains communications with the deep space network, we do anticipate to be able to communicate with the vehicle. Today's loss of signal is slated to last 30 minutes. And at this time period, we are now 1 hour away from we are now 29 minutes away from the loss of signal and about an hour away from the acquisition of signal. If you're just joining us this morning, we are bringing you live coverage of today's return-powered flyby of the Orion spacecraft, which is now 20 days into its 25-and-a-half-day test flight. While this Orion spacecraft is uncrewed as part of Artemis 2, we will have crew on board Artemis 2. Today's return-powered flyby will begin at 10:43 a.m. Central and will last 3 minutes and 27 seconds. This burn will slingshot Orion around the backside of the moon and put it in a trajectory ahead of a splashdown off the coast of California just a few days from now on December 11th. During Orion's mission, it broke the record for longest distance traveled away from Earth for a human-rated spacecraft meant to return back to Earth. On November 28th, Orion broke that record, having traveled 268,563 miles away from our home planet. During this time period, Orion was in the distant retrograde orbit. Orion remained in this distant retrograde orbit for about 6 days, in which we tested out the systems of the spacecraft in the deep space environment. Last week, the distant retrograde departure burn took place, which brought Orion back towards the moon, which we are now less than 1,000 miles away from. The DRD burn set us up for today's return-powered flyby burn. And this burn again sets us up for splashdown just a few days from now. And here is the view of the moon, as mentioned, less than 1,000 miles away. Still a little ways to go to get to our closest approach of the day, at which point Orion will be just 80 miles above the lunar surface. But we are getting closer to today's anticipated burn, now 27 minutes away from that burn, and just 24 minutes away from the anticipated loss of signal. Orion continuing to pick up speed as it closes in on the lunar surface, now traveling at 4,852 miles per hour, and now just 846 miles away from the moon. We're continuing to get a shot of the Orion spacecraft, namely the European Service Module and the Orbital Maneuvering System, or OMS engine, on the left hand of your screen there, the largest engine shown. That's actually the largest engine on the Orion spacecraft. The OMS engine is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown on 19 Space Shuttle flights. The first flight was STS-41G in October 1984, and the last was STS-112 in October 2002. And the go, no-go poll for the return-powered flyby is now underway. And the team here in Mission Control Houston did poll go for today's return-powered flyby burn. That burn will take place 23 minutes from now. And with the go from the team here in Mission Control Houston for the return-powered flyby burn, we're now just counting down the minutes until the start of that burn. Again, 22 minutes away from today's burn. This burn will last 3 minutes and 27 seconds. But just prior to the burn, we will lose signal with the Orion spacecraft. That loss of signal is anticipated in 19 minutes from now. The reason we do lose communication with the spacecraft is because it will be flying directly behind the moon, and the moon is blocking the signal to the Deep Space Network. However, once the spacecraft travels back to the other side of the moon, we do expect to regain communications with the vehicle at that time. Orion is now only 687 miles away from the moon. At closest approach today, Orion will be just 80 miles above the lunar surface. Now just 20 minutes away from today's return-powered flyby. This burn will commit Orion to a trajectory to head back to planet Earth after its 20-day mission so far. By the time Orion splashes down in the Pacific Ocean, it will have been in space for 25.5 days. During its journey, Orion has broken the record for longest distance traveled by a human-rated spacecraft meant to return back to Earth. On November 28th, Orion was 268,563 miles away from planet Earth. Right now, Orion is 239,364 miles away from Earth, but only 570 miles away from the Moon. At our closest approach today, Orion will be just 80 miles above the surface. Our next set of events will take place in rapid succession. First, we will lose signal with the Orion spacecraft as it travels behind the moon. That loss of signal will be just 15 minutes from now. Then 3 minutes after we lose signal with Orion, the return-powered flyby burn, or RPF, will take place. This burn will last 3 minutes and 27 seconds and will be completed with the Orbital Maneuvering System, or OMS engine, which you see there on your screen to the left on the European Service Module. It's the largest engine on Orion. And today's 3 minute and 27 second burn will be the longest burn that the OMS engine will have completed on the mission so far. And we're continuing to get some great views of the lunar surface as we fly just 500 miles overhead. This view coming from one of the solar array wings, or SAW cameras, as it gets into the proper position for today's burn. Coincidentally, 8 years ago to the day was the launch of the Exploration Flight Test 1, or EFT-1. This was the first test flight of the crew module portion of the Orion multipurpose crew vehicle. This was an uncrewed test flight that orbited the Earth 2 times before splashing down. Now, 8 years later, Orion is about to fly behind the moon. We're 15 minutes away from today's burn. We're now 13 minutes away from today's return-powered flyby burn. Orion is 365 miles above the lunar surface, traveling at a speed of 4,963 miles per hour. Just 10 minutes from now, we do anticipate losing signal with Orion as it begins its trip around the backside of the moon. On the bottom of your screen in the left there, you can see the solar array as it begins to move into place. You're also looking at the Orion capsule itself there, taking up the majority of your screen. You can see the kind of silver coloring of the capsule. This is the portion that when we have a crew on board as part of Artemis 2 that they will be living and working in during their trip to the moon and beyond. And in the top left of your screen there, you can see the moon as Orion glides over it, again 335 miles above the surface. But at the closest approach during today's return-powered flyby burn, Orion will be just 80 miles above the lunar surface. We are hearing that the solar arrays are configured for today's burn. Orion is now moving to the proper burn attitude. We're now 10 minutes and 30 seconds away from the start of today's 3-minute and 27-second burn. And we expect to lose signal with Orion in 8 minutes. Today's return-powered flyby burn sets us up on a trajectory to splash down off the coast of California just a few days from now on December 11th. And you were seeing some thruster firings there as Orion maneuvers to the proper attitude for today's burn. Now less than 6 minutes, 30 seconds until we lose signal with Orion. The burn will start in 8 minutes and 40 seconds. Orion is currently 253 miles above the lunar surface. Today's 3-minute and 27-second burn will take place with the Orbital Maneuvering System, or OMS engine. That's the largest engine on the European Service Module. Today's burn will change the velocity of the spacecraft by 960 feet per second during its 3-minute, 27-second burn. Closing in on 5 minutes away from our anticipated loss of signal with Orion. We will not have signal with Orion because the moon will be blocking out the signal to the Deep Space Network. However, when we swing back around on the other side of the moon, we do anticipate to regain those communications. And we are hearing that Orion is in the proper burn attitude. 6 minutes and 40 seconds away from the start of today's 3-minute 27-second burn. Just 4 minutes until today's loss of signal. As you can see from this telemetry-driven animation, Orion is now 202 miles away from the lunar surface. And you're looking at a live view inside the White Flight Control Room here at the Johnson Space Center in Houston, Texas. NASA Flight Director Judd Freeling is leading the team on console at this hour. We were tracking a loss of signal about 2 minutes and 40 seconds from now, but we are hearing that we did get that loss of signal a little earlier than expected, but that is to be anticipated from time to time. So now the next major milestone that we'll look ahead towards is the return-powered flyby burn less than 5 minutes from now. While we are traveling behind the moon, we do not have signal with the spacecraft because the moon is blocking the connection to the Deep Space Network. We anticipate that loss of signal to last about 30 minutes. And our counterparts here in this shot here in the European Space Agency Control Center in Noordwijk in the Netherlands. The European Space Agency's contribution to Artemis is, of course, the European Service Module, where the Orbital Maneuvering System, or OMS, engine is located. That's the engine that will be used for today's 3-minute and 27-second burn to propel us around the backside of the moon and commit us to a trajectory back to Earth ahead of a splashdown on December 11th. We're now less than 3 minutes away from the start of that 3-minute 27-second burn. Right now, we do not have signal with the Orion spacecraft. That is expected as the vehicle is traveling behind the moon. This loss of signal will last about 30 minutes. And as Orion comes back around the other side of the moon, we will be able to regain communications with the vehicle. Now less than 2 minutes from today's return-powered flyby burn. And you do see the team here in Mission Control stand up and stretch their legs right now. Oftentimes they'll use this time to catch a quick break while the vehicle is in the loss of signal period. Again, today's loss of signal is expected to be about 30 minutes in length. One minute until the start of today's return-powered flyby burn. "30 seconds until the start of today's 3-minute, 27-second long burn, committing Orion to a return home." "15 seconds until burn start." And we do expect the burn to be underway. Again, this is a 3-minute, 27-second long burn. Because Orion is behind the moon and we do not have signal with the vehicle, we will not be able to confirm that the burn has began or the results of that burn until we come back around to the other side and regain communications on the Deep Space Network. Today's burn is being completed with the Orbital Maneuvering System, or OMS engine. That's the largest engine on the bottom of the European Service Module. Today's 3-minute and 27-second long burn will be the longest during the Artemis 1 mission used by the OMS engine, but the OMS engine can fire for up to 16 minutes in length. Now approaching the 2-minute mark into today's return-powered flyby burn, 1 minute and 27 seconds remaining. We're approaching the 3-minute mark into today's burn. Again, this burn is critical as it will slingshot us around the backside of the moon and place us on a trajectory ahead of a splashdown off the coast of California. 3 minutes into the burn, 27 seconds remaining. and we do expect the burn to be complete at this time. Again, because we are behind the moon and do not have signal with the spacecraft, we will not be able to confirm until Orion comes back around the other side of the moon. We are anticipating that acquisition of signal about 24 minutes and 45 seconds from now. And if you're just joining us, the return-powered flyby burn, the burn that is going to send Orion back around the other side of the moon in anticipation of a splashdown next week off the coast of California, has completed. Orion is still behind the moon at this hour, and we are in a period of a loss of signal with the vehicle. We're anticipating to get that acquisition of signal back less than 24 minutes from now. But while Orion continues its journey around the moon, I do have a very special guest joining me today. This is Najud Moranci. She is the chief of the Exploration Mission Planning Office here at the Johnson Space Center in Houston, Texas. So thank you so much for joining us today, Najud.
Thank you. Glad to be here. Super special to be here for RPF.
Yeah, absolutely. It's an exciting moment indeed. This burn really commits Orion to a return journey home. But before we talk about that, I do want to talk a little bit about some of the work that your group is doing as part of the Artemis program. Now, this is an uncrewed test flight of the Orion spacecraft, but there's other components of Orion, including some robotics work that your group is working on. Can you talk a little bit about that and how it helps contribute to Artemis?
Yeah, there's a lot of different components to the Artemis as an enterprise, right? You know, Orion, SLS, this is our crewed vehicle to the moon, but we're also working on systems like commercial lunar payload service, which is delivering science payloads to the moon very soon, in the next year or so, hopefully starting those launches. And that's really the precursor for all of the logistics and the elements we're going to need as we build out a whole exploration enterprise on the surface of the moon.
That's great. I'm looking forward to seeing those land soon. And another aspect of your group is Astro Materials. So during Apollo, many lunar samples were brought back to study, but during Artemis, we're going to be landing in a different location on the lunar south pole. So how will our studies be different, and what will we be looking for this time around?
Yeah, part of our directorate includes the Astro Materials and the curation of those materials. So all of the Apollo samples that came home came here to Johnson Space Center, and we have a dedicated facility that maintains them, manages the samples to send out to the science community for investigations. And that will also happen, they already do that for other samples, like the comet samples that come back from Hayabusa and Genesis. And as we bring Artemis samples home, they'll also be managing those and curating them. And really some of the advances in the science and measurements that we can make today that we did not have in Apollo are already getting prepared.
Great. And the very last thing I wanted to chat with you about today was the moment we've all been waiting for today, the return-powered flyby burn that occurred just 7 minutes and 9 seconds ago. So you had talked a little bit about this burn and why the timing of it was important on a Twitter post that you had shared. So can you talk a little bit more about that for the folks who maybe didn't see that?
Yeah, so all of the burns are very well calculated for specific reasons. So these burns have to be executed within moments of the timing. But really what it's doing is it's timing the return trip to Earth and then targeting so that when Orion travels behind the Earth, that's when the Pacific Ocean will be underneath the entry corridor. So we're targeting for a very thin slice of atmosphere, and that's where we do our aero capture. So the atmosphere actually slows Orion down, and we need to make sure all of that is set up precisely so that we can enter the atmosphere while the Pacific is where the entry targeting is, so that we can be landing right where the recovery forces are. So there's a lot of calculations that go into it by the wider trajectory team, but this is truly our deorbit burn. So we are doing a major maneuver right now which targets our entry in 6 days.
Great. Thank you for talking through that a little bit more. Again, that burn occurred 8 minutes ago, and once we acquire signal and we come back around on the other side, we'll be able to know if that burn was successful. We're looking ahead of that acquisition of signal now 20 minutes from now. But thank you so much, Najud, for taking some time. I know you're very busy, so I really appreciate you taking a few minutes to chat with us.
Thank you for having me. Like I said, it's really important what is going on, and I'm really excited to see this burn be successful for the conclusion of the mission.
Absolutely. We're now 17 minutes and 45 seconds away from the anticipated acquisition of signal following today's return-powered flyby burn, which took place about 11 minutes ago. That burn was 3 minutes and 27 seconds and committed us back to a return trajectory headed back to planet Earth, where Orion will complete its 25-and-a-half-day test flight mission around the moon and beyond. Now, the last time NASA made a journey around the moon in anticipation of a return home to Earth was during the final Apollo mission in 1972. That crew launched nearly 50 years ago to the day on December 7th, 1972. As part of that flight, Commander Gene Cernan and Lunar Module pilot Harrison Smith walked on the moon, while Command Module pilot Ronald Evans orbited above. The crew splashed down on December 19th, 1972, and completed 3 spacewalks during their mission. And during Apollo 17, they orbited the moon 75 times. Now less than 15 minutes until we expect to regain communication with the Orion spacecraft. If you're just joining us today, 13 minutes and 30 seconds ago, the orbital maneuvering system on board Orion fired for 3 minutes and 27 seconds, propelling the spacecraft around the moon and placing it into a trajectory ahead of a return back to Earth. Orion will splash down on December 11th, completing a 25-and-a-half-day uncrewed test flight in which it broke the longest distance from Earth by a human-rated spacecraft meant to return back to Earth. At its furthest point from Earth, Orion was 268,563 miles from our home planet. We're about 13 minutes away from our anticipated acquisition of signal. As Orion flies around the backside of the moon, let's take a look back at what has gotten us to this point so far. First up, we start with the Space Launch System launching from Pad 39B at the Kennedy Space Center in Florida with its sights set on the moon. SLS blasted off at 12:47 a.m. Central on November 16th. You see those 4 RS-25 engines lighting up the Space Coast. You can also see the core stage climb up, as well as one of the 2 solid rocket boosters in this view. And on top of the vehicle is the launch abort system, and of course the Orion spacecraft now behind the moon. This video shows SLS and Orion's climb to orbit from the perspective of a camera on the rocket. It was about an 8.5-minute climb into orbit. You can see the launch pad grow smaller and smaller as the Space Launch System propels Orion into orbit. Following liftoff and the climb to orbit, the translunar injection burn took place. The translunar injection maneuver took place as the upper part of the rocket, officially named the Interim Cryogenic Propulsion Stage, or ICPS, fired one RL-10 engine producing 24,750 pounds of thrust to accelerate the vehicle to more than 22,600 miles per hour, a velocity fast enough to overcome the pull of Earth's gravity and propel Orion out of low Earth orbit to send the spacecraft to the moon. The TLI maneuver precisely targeted a point on the moon that guided Orion close enough to be captured by the moon's gravity. Now, right after that TLI burn, the interim cryogenic propulsion stage separated from Orion, and you do see that here in the video as it drifts further away from the spacecraft. Later that day, we received our first imagery of Earth, as well as completed the first checkout of the Orbital Maneuvering System, or OMS engine. All went smoothly, and that Orbital Maneuvering System engine was used just 17 minutes ago for the return-powered flyby burn, which lasted 3 minutes and 27 seconds. Several days later, on November 21st, Orion performed the outbound-powered flyby burn, also with that orbital maneuvering engine. This is the sister to the return-powered flyby burn. The orbital maneuvering burn sets us up in a trajectory to head out to deep space. The return-powered flyby burn sets us up on a trajectory to return back home. This video shows Orion as it approached the moon for this burn. And as we mentioned in this broadcast several times, Orion has traveled further than any human-rated spacecraft, but in this view here that was taken just shortly before that, you can see an eclipse, the moon traveling in front of the Earth, a view we don't often see here on Earth. And this photo was taken on Flight Day 13, November 28th, when Orion reached its maximum distance from Earth, when it was 268,563 miles away from our home planet. Orion has traveled further than any spacecraft built for humans meant to return back home. And in this video here, you see Orion's solar rays split the difference between Earth and the Moon on flight day 14. This image is captured by a camera on the tip of one of the spacecraft's 4 solar arrays. And just last week, on December 1st, the distant retrograde departure burn occurred, which placed Orion in a trajectory to exit the distant retrograde orbit and head back toward the Moon ahead of today's return-powered flyby, which occurred just 19 minutes 15 seconds ago. In this view here, you can see the solar arrays, gimbal, as well as a Earth in the almost center of your screen there. So as you can see, Orion has had a busy journey in its 20 days of the mission so far, but it's not finished yet. We have about 5.5 days to go until splashdown. But today's return-powered flyby burn was the first step in getting us to the splashdown point. That burn commits us to returning home. We anticipate regaining communications with the Orion spacecraft about 8 minutes and 15 seconds from now. You're looking at a view inside Mission Control Houston. This is the white flight control room. The flight director during today's shift and return-powered flyby burn is NASA Flight Director Judd Freeling. You do see a few of the console positions looking a little empty. That is because we are in that loss of signal period. This is a great time for the flight controllers here in Houston to grab a quick break. Today's return-powered flyby burn occurred 22 minutes and 45 seconds ago. That burn utilized the Orbital Maneuvering System, or OMS engine, on board the Orion spacecraft. At this time, the Orion spacecraft is continuing to make its way behind the backside of the Moon, and we do not have signal with the vehicle. However, we do anticipate connecting with the vehicle now less than 5 minutes and 30 seconds from now. The reason we do not have communication with the vehicle is because when we are behind the Moon is blocking the signal to the Deep Space Network. We're now less than 4 minutes away from our anticipated acquisition of signal with the Orion spacecraft, which is currently traveling behind the moon following the return-powered flyby burn. This burn commits Orion to returning back to planet Earth. This return-powered flyby sends Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft into a trajectory to return back to Earth. Now, just before the burn began 25.5 minutes ago, Orion did complete its closest approach to the moon, at which point it was just under 80 miles away from the lunar surface. Beginning to see more folks trickle back into the white flight control room as we narrow in on our anticipated acquisition of signal with the Orion spacecraft, which is currently traveling behind the moon. Now 1 minute and 30 seconds away from our anticipated acquisition of signal with the Orion spacecraft. Once we acquire signal with the spacecraft, the team here in Mission Control Houston, namely the flight controllers, will be able to analyze the data that the vehicle is sending back to us in Mission Control. With that data, they'll be able to analyze if the burn was successful. Less than 1 minute away from our anticipated acquisition of signal with the Orion spacecraft. .30 seconds away from anticipated acquisition of signal. And we are standing by for acquisition of signal with the Orion spacecraft. And we do have confirmation of an acquisition of signal on the Deep Space Network in Goldstone at 11:12 a.m. Central. You're getting a view of the lunar surface from Orion's perspective. And we are hearing good confirmation that the burn was as expected. If you're just joining us, Orion completed its return-powered flyby burn, which slingshot it around the moon and committed Orion to a return trajectory back to planet Earth, hearing that that burn went smoothly and as expected. You are seeing a view on your screen of the lunar surface as well as Earth. For Orion, this is not a goodbye, but a see you later to the moon, our nearest celestial neighbor, as we begin to get our first glimpse of an Earthrise coming into frame. In this view, we see 8 billion human lives all existing upon our pale blue dot, our blue marble, our very own spaceship Earth. And after a long journey, Orion is now coming home. From this view, Orion is 1,277 miles above the lunar surface following its return-powered flyby burn, which sent it around the backside of the moon. Orion now has its sights set on home. Orion will splash down off the coast of California on December 11th. Wrapping up a 25-and-a-half-day mission. This is a view from inside the White Flight Control Room here in Mission Control Houston. The team is being led by NASA Flight Director Judd Freeling. And this view from the Orion spacecraft as it looks to its target, planet Earth, flying over 1,200 miles above the lunar surface. At its closest approach following the return-powered flyby burn, Orion was just 80 miles above the lunar surface. The next time we see such a view, we will be hearing about it from a crew's perspective during Artemis 2. Continuing to hear good performance following today's return-powered flyby burn. The Orion spacecraft is continuing to distance itself from the moon, now over 1,500 miles away from the lunar surface. Throughout the course of the next few days, we will see the distance from Earth continue to grow smaller and smaller. Orion is now 242,000 miles away from planet Earth. The spacecraft is moving at a velocity of 2,150 miles per hour. We're continuing to get some spectacular views from the Orion spacecraft. This view is from one of the solar array wing or SAW cameras on board the vehicle. The vehicle now over 1,680 miles away from the moon. And that small sliver towards the bottom of your screen, that's here, that's home, that's us. And that is where Orion is headed next. And with today's return-powered flyby burn now complete, and Orion having completed its closest approach to the moon at a distance of 80 miles above the surface, that will wrap up our coverage for today, but we'll continue to post daily updates about the mission on the Artemis blog at blogs.nasa.gov/Artemis, and we'll also be posting updates on our social media accounts. Later today, we'll have a briefing at 4 p.m. Central where representatives from NASA will discuss today's return-powered flyby, which we hope you'll tune in for. And we'll also be covering Orion's re-entry into Earth's atmosphere and its splashdown live on air next week. But until then, this is Mission Control Houston.